I've been to places that don't exist yet. I've walked on Mars, explored ancient civilizations that vanished millennia ago, and visited planets orbiting distant stars. Welcome to the Maximus Traveler, where the impossible becomes your next destination. This channel takes you on journeys that break every rule of physics and time. We explore both virtual and real-life travel destinations across Earth and the entire universe. From hidden gems in your backyard to the surface of exoplanets billions of miles away. Whether it's through cutting-edge VR technology or actual space tourism, we're pushing the boundaries of what travel means. Some destinations you can visit today, others you can only experience through simulation, and some don't even exist yet but will blow your mind. Ready to expand your definition of travel? Hit subscribe, drop a comment about where you want to go next, and let's explore
A spark of wonder in Ulm. Good day, my YouTube channel supporters. Thanks for coming back to watch this one too. And for the new ones, don't forget to subscribe, comment, like, and share. Ever looked up at the stars and just wondered? That sense of curiosity, that little spark that makes you ask why. How? It's a powerful thing. It's the same feeling that drove one of the greatest minds in history. A man from a small town in Germany who changed the world with his mind. His name was Albert Einstein, born on the 14th of March, 1879 in a place called Ulm. We're going to take a look at his life, his genius, his best ideas. Think of it as Einstein explained in 10 simple parts. It's a story about not giving up and about never ever losing that sense of wonder. Yeah, let's go. School days and a rebel spirit school wasn't exactly Albert's favorite place. He started his education in Munich, at a school that was very rigid and strict. The teachers expected students to memorize facts and repeat them without question. This style of learning just didn't suit young Einstein's curious mind. He felt it was like being in the army, with all the rote learning and discipline. He preferred to learn things his own way, by reading books on his own and figuring things out for himself. This often put him at odds with his teachers, who saw him as a bit of a daydreamer and a disruptive influence. They didn't appreciate his constant questioning of their authority. Despite his struggles with the school system, he was brilliant at the subjects that truly interested him. He absolutely devoured maths. He absolutely devoured physics. He was so far ahead of his classmates that it was almost like he was in a different league. Albert attended a Catholic elementary school in Munich, Germany. He was enrolled from the age of 9-15 years at Luitpold Gymnasium in Munich, but dropped after his family moved to Switzerland. After failing on his first attempt at Swiss Federal Institute of Technology, he studied at Cantonal High School in Aarau for a year, then retook the college exam which he passed. Einstein studied at Swiss Federal Polytechnic School in Zurich at 17 years old, and graduated with diploma in mathematics and physics teaching. He received his PhD at Zurich University in 1905, the quiet thinker in the patent office. After a long search, a good mate's father helped him get a job. In 1902, Einstein started working as a patent clerk at the Swiss Patent Office in Bern. It wasn't the glamorous university job he had dreamed of, but it turned out to be a blessing in disguise. His job was to examine the inventions that people submitted for patents. He had to look at their technical drawings and read their descriptions, and figure out if their ideas were original and if they would actually work. This work required him to think clearly and logically, to break down complex ideas into their simplest parts. It was the perfect training for a young physicist. The job was steady and not too demanding. It gave him a reliable income and, most importantly, it gave him time. His mind was free to wander. He called this desk his worldly cloister, a quiet place where he could work on his own scientific theories without disturbance. But in reality, he was a revolutionary in waiting. The 1905 was something else. People now call it Einstein's Annus Mirabilis, which is Latin for miracle year. While still working his day job at the patent office, this 26-year-old clerk published 4 papers in a single year. Any one of these papers would have been enough to secure a scientist's reputation for a lifetime. But to produce 4 of them, all in different areas of physics, was just unbelievable. It was like a storm of genius breaking out all at once. These weren't just small adjustments to existing theories. They were bombshells that changed the very foundations of how we understood the physical world. It was a turning point for science. One of the papers tackled a mystery called the photoelectric effect. Scientists had noticed that when you shine light on certain metals, it can knock electrons loose. but they couldn't explain why it worked the way it did. Einstein came up with a radical idea. He suggested that light isn't just a continuous wave, but that it also comes in little packets of energy, like tiny bullets. He called these packets quanta of light, which we now call photons. This idea was a key step in the development of a whole new field of science called quantum mechanics. It was so important that it was this work, not his more famous theory of relativity, that eventually won him the Nobel Prize in Physics. Another paper from that incredible year helped prove something that many scientists still doubted: the existence of atoms. At the time, atoms and molecules were still just a useful theory, not a proven fact. Einstein looked at a phenomenon called Brownian motion, which is the random zigzagging movement of tiny particles suspended in a liquid like dust motes in a sunbeam. Tucked away as a short addendum to his paper on special relativity was a little equation. It was just 3 letters and a number, but it would become the most famous equation in the world: E equals mc squared. Even if you don't know much about physics, you've probably seen it. What it says is simple yet earth-shattering. Energy, E, is equal to mass, m, times the speed of light squared, c squared. In simple terms, this means that mass and energy are really just 2 different forms of the same thing. They are interchangeable. Mass is like a super concentrated form of energy. This idea was completely revolutionary. They were governed by different laws. Einstein showed that they were deeply connected. The speed of light, c, is a huge number, and the speed of light squared, c squared, is an even more enormous number. This means that a tiny amount of mass can be converted into a massive amount of energy. It's like a universal exchange rate between matter and energy, and the exchange rate is incredibly favorable towards energy. The implications of this were immense, though it would take decades for humanity to fully grasp them. E equals mc squared explains why the sun and other stars can shine so brightly for billions of years. They are constantly converting a small amount of their mass into a tremendous amount of light and heat through nuclear fusion. After the triumph of 1905, Einstein didn't just sit back and relax. He had a piece of unfinished business. His theory of special relativity was brilliant, but it only dealt with constant, steady motion. It didn't include acceleration, and it didn't include the force that governs everything: a falling apple, the orbit of the planets, gravity. For the next 10 years, he embarked on what he called the hardest intellectual journey of his life. He wanted to create a new theory of gravity that would fit with his ideas about relativity. The result, completed in 1915, was his masterpiece, the general theory of relativity. Isaac Newton had described gravity as a mysterious force, an invisible rope pulling objects together. Einstein said this was wrong. There is no pull. Instead, massive objects like the sun or a planet warp the very fabric of space and time around them. He imagined space and time as a single 4-dimensional sheet, like a stretched-out rubber mat. A bowling ball on the mat creates a dip orbiting the curve. A marble near the bowling ball rolls along the curve. The marble isn't pulled. It follows the curved path. In the same way, the Earth isn't being pulled by the sun. It's following the straightest path through curved space-time. This overturned centuries of thought. Gravity isn't a force, it's geometry. One prediction: starlight should bend passing the sun. The starlight was bent by exactly the amount Einstein predicted. Away from the blackboards and equations, Einstein's personal life was often complicated and filled with its own challenges. In 1903, while still at the patent office, he married Mileva Maric. She was a fellow physics student from his university days in Zurich, a brilliant woman in her own right. They shared a passion for science, Hans Albert. Eduard. They also had a daughter, Liesel, born before they were married. But what happened to her remains a mystery. For a time, they were intellectual partners, but the marriage became strained over the years. They separated in 1914, and the divorce was finalized in 1919. Einstein later remarried, this time to his cousin, Elsa Lowenthal. She took on the role of his protector, with the rise of the Nazi Party in Germany. The man who had reshaped our understanding of the cosmos became a refugee. After the 1919 eclipse experiment proved him right, Einstein became more than just a scientist. He became a global icon. His face, kind eyes, mischievous twinkle, famously untamed hair, became instantly recognizable everywhere. He was a bit bewildered by all the attention, once joking that it was the most incomprehensible thing to him. But he realized that his fame gave him a platform. He was a passionate advocate for peace and a strong opponent of nationalism. He supported international cooperation and dreamed of a world government that could prevent future conflicts. From his new home in Princeton, he also became a vocal supporter of the civil rights movement in America. He was deeply disturbed by the racial segregation he witnessed and used his influence to advocate for racial equality. Throughout his later years, he received countless awards and honors, but he remained a humble and approachable man. Albert Einstein passed away on April 18, 1955, in Princeton. He was 76 years old, but his legacy is timeless. He completely revolutionized physics. He changed our view of reality itself. He gave us a new understanding of space, time, gravity, energy, matter. His theories are not just historical footnotes. They are the essential pillars upon which modern science is built. Every time you use a GPS to find your way, you are relying on corrections derived from his theories of relativity. His work is woven into the fabric of our technological world in countless ways. He is remembered for his big ideas: special relativity, general relativity, his foundational work on quantum theory with the photoelectric effect. And of course, there is E just mc squared, the elegant equation that unlocked the immense power hidden within the atom. He showed the world the incredible power of curiosity and imagination. Albert Einstein's story is a powerful reminder that the most important journey we can take is the one that follows our own sense of wonder. Thank you for watching. Don't forget to subscribe to the Maximus Traveler channel. Bye for now.